In today's state-of-the-art industrial landscape, bolt manufacturing begins with the careful procurement of high-quality raw materials, typically steel alloys composed of iron, carbon, and trace elements, which are sourced from reputable mills that adhere to strict standards. These steel billets are meticulously inspected for uniformity in composition and structural integrity before being transported to the manufacturing facility. Once there, the transformation journey commences in earnest. The billets are loaded into industrial furnaces and heated to precise temperatures, rendering the metal malleable and primed for the forging process. During forging, immense pressure is applied using hydraulic presses or mechanical hammers to shape the heated steel into rough bolt blanks, a critical phase that not only imparts the initial geometry to the bolt, but also refines its internal grain structure to enhance tensile strength and durability. As the forging process unfolds, the heated metal is transformed under controlled conditions, ensuring that each bolt blank attains a consistent shape and strength. Once forged, these blanks are allowed to cool gradually in controlled environments, a process that is essential for stabilizing the metal's structure and preventing internal stresses. This initial phase lays the foundation for the bolt's performance, as it establishes the raw physical properties that will be further refined in the subsequent stages of manufacturing. The integration of modern automation and computer controls at this juncture ensures that temperature, pressure, and timing are precisely managed, setting the stage for high-quality production output while reducing human error. In this way, the very beginning of bolt manufacturing exemplifies the blend of traditional metallurgical expertise and cutting-edge technology, paving the way for a product that meets rigorous industrial standards from its very inception. Following the initial forging and cooling phase, the bolt blanks transition into the machining stage, where advanced computer numerical control (CNC) machines take center stage. Here, the rough blanks are meticulously cut, milled, and shaped to precise dimensions by removing excess material, ensuring that every bolt adheres to the stringent tolerances required for safety and effective performance. During this phase, the bolts are not only trimmed to exact length, but are also provided with the foundational shapes that will define their final utility. As the machining process unfolds, the bolts undergo the threading stage, a vital step in bolt manufacturing, where they receive their characteristic helical threads essential for fastening. Instead of cutting the threads, the process of thread rolling is employed, which presses the threads into the bolt surface. This technique preserves the metal's inherent strength while producing smooth, durable threads that can withstand repeated mechanical stress. Simultaneously, additional machining operations are implemented to fashion specialized features such as hexagonal heads, square profiles, or other configurations that facilitate efficient tool engagement and torque application. These operations require a high degree of precision, as any misalignment or inconsistency could compromise the bolt's functionality in its intended application, whether it be in automotive assembly, construction, or heavy machinery. Skilled technicians and engineers work hand in hand with the automated systems, ensuring that every cut, roll, and mill meets the high standards demanded by modern engineering. The entire machining and threading process is continuously monitored by state-of-the-art sensors and control systems, which track parameters in real time, guaranteeing consistent quality and adherence to design specifications. This phase is a testament to the evolution of manufacturing processes, where traditional craftsmanship meets digital precision, resulting in bolts that are as reliable as they are precisely engineered. After precision machining and threading, the bolts enter the finishing phase, a critical segment that includes surface treatment, rigorous quality control, and final assembly. At this stage, the bolts are coated with food-safe or industrial-grade finishes, such as beeswax, mineral oil, or lacquer to protect against moisture, corrosion, and mechanical wear, while simultaneously enhancing the natural appeal of the metal. Depending on the intended application, methods like hot-dip galvanizing are employed, wherein the bolts are immersed in molten zinc to form a robust protective coating, or chemical passivation techniques are used to remove impurities and create a stable oxide layer on the surface. In addition, the manufacturing process may incorporate advanced heat treatment steps, such as quenching and tempering, where the bolts are rapidly cooled from high temperatures and then reheated to a controlled level. This heat treatment achieves an optimal balance between hardness and ductility, ensuring that the final product possesses the necessary resilience and strength for high-stress applications. Concurrently, the bolts are subjected to rigorous minimize downtime and maintain continuous improvement in production efficiency. The final assembly process also often includes labeling and bundling the bolts with precise documentation of their specifications, information critical for users in sectors such as automotive, construction, and heavy machinery. Sustainability is also a key consideration in this phase. Manufacturers adopt environmentally friendly practices by recycling scrap metal, reducing energy consumption with efficient machinery, and implementing lean manufacturing principles to minimize waste. In essence, the finishing phase transforms the precision-engineered bolts into a market-ready product that embodies the seamless integration of traditional metallurgical techniques and cutting-edge technological advancements. Each bolt that completes this phase stands as a tangible representation of industrial excellence, engineered to perform reliably under diverse conditions and to support the safety and longevity of the systems it ultimately holds together. As digital innovations like additive manufacturing and smart materials continue to evolve, the process of bolt manufacturing is set to become even more refined, ensuring that this humble yet critical component